Okay, hello, this is the last video. It's going to be fantastic. You're not ready for this. Okay, ready? So, a function specifically is a quadratic function if it's of the form f of x is equal to ax squared plus bx plus c. Easy enough. Okay, now what do we know? First we know, is this an even function or an odd function? You need to know what this is, because I'm going to tell you, but you also need to know, just like, because we've already covered this. It's a polynomial, yeah? This is an even function. And what do we know about the end behavior of even functions? Again, you should know this, but I will remind you if you don't. The end behavior of even function is symmetrical. That is, both sides either open up or both sides open down, okay? So symmetrical end behavior. How do we know if it opens up or down? If a is greater than 0, up, a is less than 0, down, and a can never be equal to 0 or else it's linear. Okay? So a will not be 0. I will never give you an a that's 0 because that's a line. That's a line. Okay? Okay. Now, last lecture we talked about completing the square. Okay? And I vaguely talked about the form f of x is equal to a x minus h squared plus k, which is also called Vertex form. Okay? This is also called like standard form. Okay? So, what do we know about vertex form? Well, the a is the leading coefficient, yeah. The a is the leading coefficient. It tells us what the end behavior does. So in the same way as this a up here, if a is greater than 0, up. If a is less than 0, down. And where does the vertex part of vertex form come in? The vertex is going to be h comma k. Do you notice how this is negative h? Yes, when you have a vertex, you have to switch. Okay, you have to switch the sign. All right? Okay, why is this important? I'm so glad you asked. Okay, y'all aren't ready for this. Okay, you're not ready for this. Okay, so you guys remember how I was like waxing poetic about like the different forms and whatever in the last video? Right. We'll see how it all connects and how it all suddenly magically makes so much sense. Hear me out, okay? Let's look at it as a factor. Let's factor this, put it into factored form, okay? We put this into factored form, right? And we're gonna put our little scratch work on the side. You have this, you can factor the 2 out of all of these, right? So you have 2x squared plus 6x minus 7 is equal to 0, right? And we know that internally, right, this can be factored into, well, 2 different things, right? You know that multiplies out to negative 7, adds up to positive 6 is going to be plus 7 and minus 1, right? So this can actually be written as 2 times x squared plus 7x minus x minus 7 is equal to 0, right? And if we just kind of ignore the 2 for a hot second, right, you can actually write this guy as 2 parentheses and just treat this as an internal thing, yeah? You can kind of group these 2, you can group these 2, and that should leave you with x plus 7. You factor out a negative 1 here, you end up with an x plus 7 on the inside. No, not that color. It's equal to 0, right? Traditionally, if we want to just solve for x, we could just divide everything by 2 and call it a day, right? But I'm proving a point, okay? Proving a point. This can faithfully be written as 2 times x plus 7, right? And x minus 1 equals 0, right? right? You know, factor blah, 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 whatever, right? But of course, since this is all being multiplied, we can faithfully write it as 2x plus 7, x minus 1, and this guy's going to equal 0, right? So in factored form, we have 2 parentheses x plus 7 parentheses x minus 1 is equal to 0, right? Great, fine. And of course, we know that the solutions are x equals -7 and +1. Cool. Nothing crazy here, right? All seems reasonable. Okay. If we wrote this in completed square form, right? Well, let's do the scratch work on the side. It's 2x squared plus 12x minus 14 is equal to 0. Okay. 2x squared plus 12x minus 14 is equal to 0. Let's say I want to complete the square without dividing by 2. I want to factor the 2 out so like squares behave, but I don't want to divide by 2, thereby losing that coefficient. Does that make sense, right? If hypothetically we were to do that, right? Hypothetically, we would say, oh, well, I can pull the 2 out for sure, like that. We're not dividing, we're pulling it out. That leaves you with x squared plus 6x minus 7 is equal to 0. This looks a lot like our last step, or our last process. That's fine, it's the same equation, right? Okay, well, how do we complete the square, right? Visually, what we want to do is we want to say this becomes a perfect square, and then we have this guy, right? And then we have this guy. Okay, what I'm gonna do for you is I'm actually gonna block it out so you can kind of visually see me separating everything, right? So the 2 was like your annoying little brother that you know, kind of have to drag along because mom said so kind of thing, right? And that leaves you with 2x squared plus 6x minus 7. And this is equal to 0. We actually haven't done anything, we just made it look better, right? We made it look nicer. And as we established, when we complete the square, we can kind of shimmy this guy to one side, right? We don't actually change anything, we're just doing some rewriting, yeah? I haven't changed anything. These are actually just the same statement, right? Okay, back to completing the square. We want this guy. We want that guy, right? Okay, if we want that guy to be 2bx, right? Because it's x squared plus 2bx plus b squared, right? Which is reminiscent of a squared plus 2ab plus b squared, right? You know that b must equal 3. If you're not sure how I got there, review our last video, okay? If you know b is equal to 3, then you know that b squared is equal to 9, right? And so in this way, you can write your big old thing as x squared plus 6x plus 9, close. All of a sudden, our equation is not balanced. These are not the same. Even if you put the -7 in right here, right? These are not the same. How do you make them the same? Well, if you add in here, you've got to subtract in here or add on this side. My personal recommendation to prevent algebra oopsies is to subtract in here, right? What I mean by that is, if I say like x is equal to 7, right? And I say x plus 3 is equal to 7, that's not true anymore. This is true, okay? I don't recommend you doing it on this side only because you will have some room for error, okay? You will have a lot of room for error. So if we add 9 on the inside, we should subtract 9 out here. Hear me out, it will make sense. And notice how this is all wrapped inside of that green, right? It's all wrapped inside of the green. That's important because we're completing the square inside of the green, okay? Very, very important. And if you do this, you'll find, oh, well, this is the same as saying 2 big old parentheses x plus 3 squared. Negative 9 minus 7 is negative 16. And this guy is equal to 0, right? But what did we say vertex form was again? We said vertex form was ax minus h squared plus k. We have something inside of, we have a constant inside of parentheses, and that parentheses not being squared. So we have to do a bit of magic, okay? What we can do is we can distribute this too, yeah? And that leaves you with 2x plus 3 squared minus 32 is equal to 0, right? And if you were to finish completing the square and you solve for all your bits and pieces, right? If you were to solve it out, you'll find 2x plus 3 squared is equal to positive 32. You divide by 2 on both sides. X plus 3 squared is equal to 16. Square root both sides. X plus 3 is equal to positive negative 4. X is equal to 4 minus 3, positive 1. And you also get negative 4 minus 3, which is equal to negative 7. So in completed square form, you're looking at 2 parentheses x plus 3 squared minus 32 is equal to 0. And your solutions are once again negative 7 and positive 1. You see where I'm going with this? Okay. Now, suppose you want to quadratic formula. You go negative b, so negative 12 plus or minus the square root of b squared 144 minus 4 times a times, what is c, negative 14, all over 2a, which is 12, right? X equals, which is equal to negative 12 plus or minus the square root of 144 negative 4 times 2 is negative 8. Negative 8 times negative 14 is positive, 80 plus 32, 112. Positive plus 112 all over 2a, which is 24. Please don't simplify yet. Negative 12 plus or minus 144 plus 112 is 256. All over 24, the square root of 256 is not low power mode. It's 16, I was right. Negative 12 plus or minus 16 all over 24. No. Which means you have two solutions, negative 12 plus 16 over 24, or negative 12 minus 16 over 24. Negative 12 plus 16 is... Why is it 1/4? Sorry, minor typo. This shouldn't be times 12. I don't know where I got 12 from. This should be beep, 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 times 2. A is equal to 2, my friends. I am not immune to typos. I was like, these numbers are huge. 4 over 4 is equal to 1. Negative 12 minus 16 is negative 28 over 4, which is negative 7. Solutions are all the same. Cool. We know how that works. But why is this relevant for graphing? I'm so glad you asked. Because if we get rid of all of this baloney, right? If this were a function instead of an equation, right? That is to say, f of x equals this, right? Hear me out. All of a sudden, you can start doing things like this. And you can start saying things, no, not like that, like this. And of course, it is what it is, right? all of a sudden, you know what the zeros of your parabola are. If you do, I personally recommend completed the square form, so vertex, to get the vertex form, I recommend vertex form, and depending on if it's nice and factorable or not, either factor form or quadratic form, you don't need both. And sometimes the completed square form actually just gives you factored form if there's only one solution, right? Anyway, all of a sudden, you know your zeros. The first zero is at 1, right? Positive 1, let's put positive 1 right here. Your second zero is at -7, so 1, 2, 3, 4, 5, 6, 7, just like that. Okay. And you can get this based off of either quadratic form or factored form, right? Completed the square form, vertex form. What does vertex form tell you? Vertex form is ax minus h squared plus k. Okay. This we can actually just rightfully rename. Right? What is your a? A is equal to +2, which means your parabola opens up. You know it does this. And h is equal to -3. K is equal to -32. Oh, and that's your vertex, we say. Oh, so let's say, oh, if your vertex is at h is equal to -3, that's your x value. 1, 2, 3. And let's say like -32 lives down here, right? You all of a sudden have a vertex at -3, -32. And that so far is matching. And then you can just go, oh, I know how that works. I could just curve this, just, oops, not like that, like that, right? All of a sudden, you have a perfectly well-formed parabola. And then you're like, oh, but Amanda, how do I know I did it right? There's a neat little feature called the axis of symmetry. It's a vertical thing, right? The axis of symmetry should be halfway between the first zero and the second zero. Of course, if there's only one zero and you just hit the x-axis, right? Distance is 0. Vertex is the axis of symmetry. Of course, again, if your parabola doesn't have zeros, let's say it's like floating around somewhere, right, and never hits the x-axis, then you don't have zeros and that's fine. But oh look, if you hit 0, and you hit the x-axis, you find, oh, this is actually a distance of 4, and this is also a distance of 4. And your axis of symmetry is at x equals -3. That's it. It's actually stupid, silly, easy. Let's do I'll give you guys some problems and call it a day. Okay, for your grade scope, we want 38 to 50. It seems like a lot. It's not. Half of it is matching things. And you're done. Thank you so much, guys. Yay, you completed algebra. I'm so proud of you.